Now, I hope everybody is fine. In this video, I'll be talking about LS coupling, and uh, and it's a normal kind of coupling. And in this case, what we have, the various electrons in an atom, they have their own orbital angular momentum, and they have their own spin angular momentum. So each electron in an atom has its own spin angular momentum and orbital angular momentum, and all the orbital angular momentum vectors of the electrons, all the electrons that we have in atom, they combine to form the resultant L. So L is a vector, okay, and similarly all the spin angular momenta vectors that are associated with all the electrons have a resultant S. Now the resultant vector that is L and S combine to form J. They combine to form total angular momentum J. And this J represents the total angular momentum. So if I think in terms of L1 plus L2 plus L3 as individual angular momenta of all the electrons in an atom, then in terms of the spin angular momenta of all the electrons in this atom, this gives me the total angular momentum J. So this type of coupling that we have, we can see, we call this type of coupling as LS coupling, and this type of coupling is basically it's governed by that all the three, all the three vectors that we have, L, we have S, and we have J, they have to be quantized. They are quantized. And this L, orbital angular momentum, it's an integer, including zero. And so to say, this L is what we know is 0, 1, 2, and so on and so forth. And spin S that we have, this spin is also an integer or half integer. Now this spin can be integer and it can be half integer depending upon the number of electrons. Depending upon the number of electrons and the direction of their spin, so there has to have a resultant of the spins that we have. Now, if I choose a case of now if I choose a case of now if I choose a case of one electron, okay, so for one electron its spin angular momentum is 1 by 2. And if I choose a case of two electrons, now S in that can be either 1 or 0, depending on the orientation of these spins. They can adapt to each other, or they can cancel out each other. That should be the case. So it depends on whether the spin that we have for two electrons. It can either be parallel. If they are parallel, then we will have 1. If they are anti-parallel, then we will have 0. Now, in case of 3 electrons, if we have 3 electrons, then for 3 electrons, what possibilities we have? It can be 3 by 2, or it can be 1 by 2, depending on whether the spin vectors are parallel or anti-parallel. So, so this is how this is done. And so, if we have an example of 4 electrons, Now, what in this case? In this case, S can have two. It can have value equal to 1. It can have value equal to 0, due to the same reasons that I talked about: one electron system, two electron system, three electron system, and four electron system. So thus I can say that this S is an integer. This S is an integer for even number of electrons, and it is half integer. It is half integer. Quite clear, very simple. It's half integer for odd number of electrons. Odd electrons. This is even electrons, this is odd number of electrons. And since J that we have, the total angular momentum, it's the vector sum of L and S. Is the vector sum of L and S. Therefore, this J will have the values. It will have integer values 0, 1, 2, 3, etc. When this S is an integer, it can have those integral values for even number of electrons. Quite simple, because S has that dependence. And similarly, this J will have it will have half integers. It will have half integer values, say 1 by 2, 3 by 2, and so on and so forth, for odd number of electrons. Now, when this S is half integer for odd number of electrons. So J is always positive. This total angular momentum is always positive. Why? Because it represents the total angular momentum of atoms. So this J is total angular momentum of atom under consideration. So that's the case. So we can understand for this, if we have single electron, we will have 1 by 2. If we have two electrons, we have a possibility of two spins in the same direction, or we can have anti-spins. The same story will go with three electron system, four electron system, and n electron system. And finally, we will have even odd situations. If we have odd number of electrons, J will have a fractional value, and if we have even number of electrons, this J will have it will have its direct integral values.